Hello, AAG students. So I wanted to make a video because I'm getting some questions about, just some of the old polynomial, topics and how it relates to our equation of a circle. So basically, I just wanted to go back to some things that I think should be familiar for you, all right? So right now we have what we call polynomials, right? These are in factored forms, right? Here's one factor, here's another factor. So if we wanted to just multiply these, all right, I'm pretty sure most of us should remember that we're basically going to use the distributive property, right? It's kind of like double distributive property or FOIL. But I'm going to take x times x. That's going to give me x squared. X times 7, positive 7 will give me plus 7x. Negative 4 times x is minus 4x, and then minus 28. Okay, so I distributed the x first, then I distributed the negative 4. But now if you notice in here, guys, we have like terms. I'm going to carry down the x squared and the minus 28, my first and last terms. But if you notice, we are adding together positive 7 and negative 4 as the coefficients to give us 3x. Okay? Now, there was a shortcut to this when we first learned this, right? So basically, you know that you're going to get x times x or x squared. You know the last term is going to be the product of these two numbers. But the middle term is actually the sum of these two numbers. So if I take negative 4 plus 7, that gives me 3. That's the coefficient of x in my middle term here, right? So we call this standard form, all right? So basically it's expanded. It's written in descending exponential order, right? Squared, right? X is really to the first, and this has no x or x to the 0. But anyway, all I wanted to show you was how to expand from factored form to this form, okay? Next, when the factors are the same, and that's really what we're going to focus on here. When the factors are the same, I could have written this as x minus 5 quantity squared, okay? Because it's basically one factor times itself, or that factor quantity squared. But there's something special that happens here when the factors are the same. They're identical. So I'm gonna play this out, right? So I'm gonna multiply and distribute my x times x is x squared. X times negative 5 gives me negative 5x. Now, I'm going to actually get the same term here again in the middle. Minus 5x, and at the end here, I'm going to get a perfect square, right? Because negative 5 times negative 5 is positive or plus 25. Now, if you notice, we are going to end up with x squared minus 10x plus 25, okay? So I want you to notice something here. If I go look at this quantity squared term here, if I just take negative 5 and double it, it gives me the middle number. And if I take that number and square it, it gives me the last. Okay? So let's keep it going here. As you can see, these are all in the same format. Now, if I wrote this out, right? If I wrote this out, x minus 9 quantity squared, it really means x minus 9 times itself. Now, I want to try to use a shortcut here, right? Let's think about this. We know the first term is going to be x squared. The middle term is going to be negative 9 plus negative 9, or negative 18x, okay? I could have also taken negative 9 and just doubled it. And then the last term is going to be that negative 9 squared, or 81. As you can see, I have a perfect square in my last term here, and I have double that number in the middle. All right, from here, I want to just, by now, after doing these couple examples, I want to jump right to the final expanded version of this, right? We know it's going to be x squared. The middle number will be double that, so it'll be plus 24x plus 144. Okay, so the first part of this video, I just wanted to just talk about reviewing some old polynomial information and expanding or using distributive property, okay? Now, I want to take the relationship that we just talked about here, and I want to apply that to the next part of the video. Excuse me. So, what we want to do is we want to create perfect square trinomials. I'm not really so concerned about the vocabulary for this, guys, but I want you to notice that when we took these two terms and squared the whole quantity, it gave us what we call a perfect square trinomial. The number in the middle is double that number. The number at the end is that number squared. So this is a perfect square trinomial. So what we want to do is we want to try to recreate this, okay? Eventually, this is what we're going to be using in our equations of a circle. But here we go. So I want you to notice that this number is a perfect square, right? Just like we went back here. So what would I do to 144 to go back to 12? Well, I would take the square root of it, right? So I want you to notice that the variable is a, so I know that this is going to be a, and look, they're all positive, a plus something quantity squared, right? So what is the square root of 64? Just like back here, the square root of 144 was 12, so I'm going to take the square root of 64 and write it as 8, okay? Now, if this was a two-term polynomial or a binomial squared, then we should know that we're going to get, look guys, these situations here, where the number in the middle is double that, number in the middle is double that, right? Number in the middle is double that. And the number at the end, the last term, is always that number squared. That number squared, that number squared. So over here, 8 squared is 64, and double that number would be 16a. All right? So what I'm trying to get you to realize is we're kind of going backwards now, right? If we want this perfect square trinomial, then we need one term times itself. So what this was, or what this could be also written as, is a plus 8 times itself. All right? Now, I'm just going to keep it moving here, right? Eventually this is hopefully going to all come together. But again, I want to create a perfect square trinomial. But now if you notice, I have different information than I did in the beginning. Well, I know that this front term is going to be m times m, right? So maybe I'll continue this version, this format for this last type, right? I'll put m here. There we go. M times m. Now I notice that I have subtraction here, so that's going to be minus and minus. So let's think about this, guys. The pattern that we noticed so far is that the middle number was always double what that number is, right? Or it's like adding two of the same numbers. So what I'm going to do is I'm just going to divide this in half. So I think this is going to be m minus 6 and m minus 6, right? So as if I added those two together, there's my negative 12. Now, m minus 6 times itself is m minus 6 quantity squared. But what would this last term be? Well, let's think about it. It would be negative 6 times negative 6, or negative 6 squared, which is 36. Now, this is a perfect square trinomial, and it can be factored to look like that, all right, as a binomial square. All right, again, don't worry too much about the vocabulary. Hopefully this pattern is making sense. So let's think about this. What do I do to the middle term? Well, I'm going to break it in half, just like we did to the negative 12. So half of that would be, I'm going to put my p's here, right? P times p is p squared. And then I think it's going to be all positive, right? I think it's going to be plus 4 and plus 4, right? This way, 4 plus 4 is 8. 4 times 4 is 16. And this can be factored or rewritten as p plus 4 quantity squared. All right? Now this last one has a very, very, very big difference, okay? I want you to notice that in every one I've done so far, the leading coefficient has been 1, right? This is 1a squared, but we don't write the 1. 1m squared, 1p squared, but this is a big difference here. This is 3w squared. That tells me right away that I need to factor out that 3. Right? So I'm going to divide out 3 and put it out in front. Okay? And then I want to see what's left. So 3w squared. If I divide out the 3, the only thing left is w squared. If I divide negative 48 by 3, that leaves me minus 16w. And now I have plus something. Right? So now if I just take my pen and just cover up the 3, I'm now back to all of the same examples up here. I'm just dividing out the 3 and putting it out in front temporarily. So let's go ahead and ignore the 3 for now, right? And let's ask ourselves, if that is the sum of two of the same numbers, then I'm thinking that number is negative 8, right? So again, ignoring the 3 temporarily, all I'm focusing on is this trinomial. So I know I'm thinking it's going to be w times w. It's minus, so I'm going to have w minus something, w minus something. And now let's think. I'm going to split up the minus 16 into equal numbers. So minus 8, minus 8. Now, I can rewrite this as 3 times w minus 8 quantity squared. All right, and finally, what would be this number here? This is tricky, and this is going to come into play in our next video, but watch. What was this? minus 8, so that's going to be 64, right? But be careful, guys. We divided out 3 earlier, so in order to write this out in fully expanded in its fully expanded version, I'm going to have to multiply 3 times 64. 3 times 60 is 180. 3 times 4 is 12. So this would have been 192. Okay, finally, just to kind of put this all together, part 3, how does this fit into our study of circles? So what I did here was I wrote a standard form equation of a circle. Now this is in standard form. Remember, guys, in our last couple videos, we had x minus h, quantity squared, plus y minus k, quantity squared, equals radius squared. So if I was trying to graph this, I would kind of take out the important information. Now remember, h and k are your center, is the center of your circle, right? So I'm going to just do a quick little review of that. So my center would be at positive 2. Remember, we take the opposite sign. And negative 7. That would be my center. The radius, remember, 9 is the radius squared. So we'd take our square root. So if I wanted to graph this, that would be my important information, center and radius. But I wanted to go back to all of the stuff that we just talked about and see how this relates to our equations of circles. Right now, this is in standard form. What I'm going to do is expand the whole thing and show you what general form looks like, okay? So here's what I'm going to do. After what we just got done talking about earlier, guys, see like x minus 9 squared? Well, that's this little component here. That's this x part here. So I'm going to expand this. I'm going to write this as x squared. Now remember, double the number, square the number. Okay? Now I'm going to do the same thing for y plus 7 quantity squared. I'm going to have y squared, double the number, square the number. And I'm going to bring down my 9, equals 9. Now you can start to see that I have no more parentheses. I'm starting to expand this. Okay, 4 and 49 are like terms. And now what I'm going to do is I'm going to just kind of rewrite this. X squared minus 4x, so now I have the x parts, and then plus y squared plus 14y, right? And what I'm going to do now is put 4 plus 49 together, which is 53, right? All right, and then what you'll notice on a lot of our examples is they might write this in what we call general form, and what we would do is we would subtract that over, right? So if I finish this up and say x squared minus 4x plus y squared plus 14y equals, now I'm going to have 9 minus 53, right? Which is going to be negative 44. Okay, guys? So I want you to notice that this is going to start to look like the Khan Academy and IXL questions that you've been working on. So I'm going to put together a part 2 video, and this will then show you how to complete the square, because that's really what we're doing here, right? Review of polynomials, review of perfect square trinomials, and now we're going to start to fit it in with our study of circles. All right, guys? So with that being said, I'm going to say goodbye, and I'll see you in the next video.